The next part of the day will be all about X++. This is a deck I created basically for this. So it's based on the type of questions I typically get from people who started learning X++. X++ at a glance. It is a curly bracket language. That's like a family class of languages like C# and Java. They have these curly brackets, so that's how you recognize them. So it looks familiar. I mean, it's not hard to read X++ really. It is also a .NET language, so it's now compiled into CLR and executed by the Common Language Runtime, which is part of .NET. So we only have a compiler for X++. We're running on top of .NET. So everything you know about debugging, troubleshooting .NET, you can do. You can use ILDASM, you can use JetBrains tools, you can use all of that because it is IL code at the underneath everything. That sometimes refer to it as a managed language. When we use that term, it's basically because it's a .NET language. And it is object-oriented, of course. It is like any modern language these days. It was designed for simplicity. We want to take away some of the complications to allow engineers to focus on the business problem. And one of the reasons for that is that a lot of the people who are building business applications do not have a computer science degree. They have a business degree. I mean, most of us in this room have a computer science degree, and we're struggling with learning the domain. But many of the users of this are actually someone with a business understanding who needs to learn how to write software. So we want to make that as simple for them as possible. It got complicated. It is a complicated system, and there are many things once you get into object orientation and all of that. But some of the design decisions we took was based on we want to keep it simple. And here are some of them. X++ is case insensitive. And that's something you need to get used to. And the whole idea here is, why bother with, did I get the casing right when I'm typing stuff? Let's just make it all case insensitive so everything just works. Very nice idea, but since everything else is case sensitive, it's a little bit hard to understand. When we're then compiling into IL, which is case sensitive, it becomes a little harder, but the compiler is taking care of that. So when you define a type, it has some kind of casing. So when you compile it, will use that casing when it puts it into CLR, which is nice. Another problem is that when you type in some name, if you use C#, if you start with a capital letter, it means something typically for a type, whereas a variable you use lowercase, then there's two different things because it's case sensitive in X++. The compiler cannot tell them apart because both would go, which means that it's a little bit harder for the compiler to actually figure out what you mean. And it can also make it a little bit harder to read the code because you can use whatever mumbo jumbo you want. So the compiler actually made it harder for itself there. And there are some implications of that. I'll give some examples on that later, but it is case insensitive. When we started out, X++ didn't have access specifiers, so private, protected, public. We didn't have any of those. So you just wrote void, foo, whatever, right? At some point, we realized, hey, we need access specifiers. And then since there was so much out there to not break anyone, we said, hey, let's make public the default. That's very different from other languages. Here, private is default, you open up. In X++, it's mostly the other way around. You need to close it down. So methods are public. Fields on a class, for example, they are protected by default, which means that all derived classes have access to them, but no one else. You can mark them as public if you want or private, but by default, they're protected. All methods are virtual by default, which means that if you create a derived class, you can then override the method. If you don't want people to override it, you can opt out by marking the the method as final. But if you don't do anything, people can just extend and have access to everything. The way people typically count is like one based, 1, 2, 3, right? In C#, it's 0 based.
Everyone zero.
That somehow makes it easier to write software in some cases, but we decided to make everything 1 base, so the array 1 is the first element. Something you need to get used to. Back when it was truly a X++ own language, it wasn't that big of a deal. But now, since we actually are a .NET language and you can use all the .NET APIs, you need to be careful because you will, if you write system.object_array, then it is a .NET array underneath, and then it's 0 based. But if you use the built-in types in X++, it's 1 based. You know, the Roman numbers, they didn't have 0 either, right? So, if you have a type, it can be converted to Boolean automatically. So you can write if my object, which means if it was in C#, you write if my object is different from null. Right? So you don't need this different from. It also works for strings and dates and integers. And if it has like the default value, which is like 0 blank, something like that, that would be what we compare to with to make it a Boolean. So when you read the code, you need to write a little bit less. So it's kind of nice. When I write C#, I always forget this and I need to add it in. So I kind of got used to this shortcut. And then we have no method overloading. So overloading a method is you have two definitions of the same method with different parameter profiles. We do not support that. The reason for that is based on the layering I told you about earlier, because here when you start editing a method, we'll take a copy of that entire method and put into your layer, so you had your own version of it. And here the key for that element, which let's say it was the name of the method, right? So now if you could edit the parameters, which you could, then that would make it a different method. And so we just decided no method overloading. If you want multiple methods with different parameter profiles, you need to give them a unique name. Yeah, that one is not too big a deal. You just need to be aware, because if you start, hey, why can't I? Then that's why. We do have optional parameters. C# didn't have that to start with either. But X++ has it, so if you really want to have different parameter profiles, you can still have it, but it's like optional parameters. Okay. The way to recognize X++ is really by the SQL-like constructs. So tables are really objects behind the scenes. So what we have here highlighted in yellow is a while select for update statement, where we are selecting a table called format mapping table, which is defined on the line above. Some mapping here. The example doesn't matter too much, but it's just the syntax that's interesting here. So you have a select where clause, and then the blue is the type, the variable, and see the green, we're actually calling some methods on it. Right, so how the heck does that work? Because typically on a data object, you cannot call a method, but in X++, you can define methods on tables. And a while select is basically, as you expect, a while loop. So this thing will be looping over here as long as it can find records in the database that matches the profile here. And then it will automatically create a new object of this type, do everything you have here, and then garbage collected, create a new object of that type. So you don't see an object instantiation or anything like that. You just write while select, the language takes care of all of this. And this is a very trivial example. You can have joins and field lists and all sorts of things. So it's actually like a somewhat simpler. T-SQL can be really cumbersome to write when joins and everything. So this is slightly simpler. And the reason for that is we had to support or wanted to support multiple databases. So it could be SQL, Oracle, DB2. So we have kind of our own format here, but it looks very much like SQL, and you'll get used to it. It's very, very simple. And it's fully supported by the compiler. If you type up something, a field that doesn't exist, or you're saying equal of a string to something that's not a string, a date, for example, it will complain. So this here is a method on that table. And all method tables, you can add more logic. So if you debug through here and you click into the update, it will not go directly to SQL first. It will actually run some other X++ logic defined on this table, if that is there. Right? But here you could have, when you update this one, you should also update that table and do something else, or do some calculations, whatever defaulting values, whatever you have. So it is just a method, it is just an object, and eventually it will end up in the database. So inside this, there will be a call to super. Super means call it on the base. On the base on the table is basically go to the SQL. That's a platform data layer that will do that, will convert it into a SQL statement. Okay. Access specifiers, they work exactly like in C#, with the exception that default is public. But otherwise, public means what public does in C#. Protected internal means the same, protected internal and private. There's this odd combination called private protected, that you have in C#. We do not have that one in X++, but otherwise it works exactly like you would expect. Our recommendation is that you're explicit just to make sure that everyone understands your intention instead of assuming that people know if I don't write anything, it's public. If you want it public, write public. If you don't want it public, then write whatever you want, but be explicit. Then it's just easier. That's the best way to avoid these issues. So if something is public, then anyone, regardless of where they are, can reference it. The exact opposite is private. It means only within your model, within your class can reference it. If something is protected, which is in X normal, then anyone within your class hierarchy can access it. But also if someone else is extending the class in a different model, they can extend it. If they have access to it, they can call the method, they can change the logic. Now, these are the simplest ones. Then we have internal, which means basically it's public, but only within my assembly. That's this. We just like in our model assembly, it basically means the same thing. We also have a notion of friendly assemblies, so we can make things friendly, and that means internals visible to your friends. That means that they can also see the internal thing. We use this for testing quite a lot, right? But otherwise, internal is, if you write internal, it means it's Microsoft. It also means that you can edit the signatures, delete the method, whatever, no one else can have a reference to it, so that's safe. And then there's a protected internal, which means that from the outside world, it's protected. From the inside world, it's internal. So that's like the union between these two. That one is a little bit confusing. Some customers say, oh, they put internal on, that means I cannot use it. But that's actually not true. It just means it's protected, but we would like to access it outside the class hierarchy. You can read the documentation on C# as well. It's exactly the same. It's also compiled into the same CLR, so that's why it actually does work just like that. Now I will go through some of the data types in X++. There's of course all the basic ones in strings. I don't want to talk about them. They behave just like you expect, but there are also some special ones. There's one called a container. And the original idea behind that was that in a 3-tier architecture, you need to move packages of data from one tier to another. And you want that to be in one blob thing. So that's why we have containers. So if you need to store an image, for example, in the database, you define the column for that as a container. But it can also be used in X++. So you can write container C equals, and then the square brackets is a container. So this will create a container with 3 elements. The first one being a Boolean with the value true, then an integer with the value 1, and then a container inside the container that has 2 values, a string high and the integer value 5. It's kind of a nice way of building things up. You can also unpack a container very easily. So you can say XYZ equals C, then X will be Boolean, true, Y will be an integer 1, and C will be a container with those 2 values. Now, you better declare these correctly because the compiler will not validate it. If these are all integers, you'll get runtime error. Then there's some peek and poke commands if you want to play around with the contents of the container. So conpeek will give you the second entry, which is the integer 1, which is good. And conpoke will basically change value number 3 to new value. So it will replace this container with a string new value and then return the container so you have a new instance of the container. These containers are actually super fast behind the scenes, and that's because it's compiled into a system.object array. The X++ compiler is converting everything into something that makes sense in the CLR, and that's what happens underneath here. You may see these being used to return multiple values from a method. I mentioned it before, you have tuples in C#. So you can do the same here. You can return a container with 5 values and unpack them on the other side. But unlike C#, where you actually have the type definitions and the type checks of the contents of the tuple, we do not have that in X++. So you better agree with the caller and the receiver of what the contents of this method is. So it's somewhat fragile. And a better way of returning multiple objects, create an object, values, create an object and return that, then you can easily add more to it, right? So there are better ways around it. But the data type is here and it can be useful. It's very dynamic. It's an array system.object array. The next one is any type. And any type is special because you can declare it if you don't know what type you want. And then the type, it's unlike the var keyword where the compiler is inferring what type it is, and you get a compiler error if you cannot determine it. Here, the compiler don't care, right? It will just tell the runtime that first time something is assigned, then I assume the type I am. Okay. So here, A1 becomes an integer, A2 becomes a string. If I do A1 equals A2, then I'm basically saying that an integer should have a string value to get a runtime error. So it's not ideal to do like this. So you only want to assign to an any type once inside a method. I think there are a few cases. One of them is if you want a method that can take multiple types, since we don't have method overloading. So you can say any type, and then inside your code, you can say, oh, if A is a string, do this. If A is an integer, do that. Right? Then the compiler will just accept everything. It's dirty. It's not ideal, but that's one use case. Another thing is in .NET, you have the thing about C# about boxing, where basically an integer can become an object of a type. So basically, you have a reference type, right? So somehow in C# you can make everything an object. So the base of everything is an object. That's not true in X++. In X++, the base of everything is any type. So we needed something that was like the common root. So object is an any type. A table is an any type. A container and an integer, they're also any type. So at the root of our hierarchy, you have any type. And the compiler allows you to assign anything to it. You typically do not use it. If you want boxing behavior, there's another one called sys any type that behaves like where it will actually do the boxing. We hardly ever use that, but it's there. Do you guys know about what clean code is? Clean code is the idea that you create very small methods that has one purpose only, that's well defined, as small as possible. If you write code like that, then any type would behave fine, because if you declare an any type, it will just do one thing, it'll just be one assignment. The common mistakes we see is there's some loop iterating over an any type, and you define the any type within it, and then suddenly the type is changing. Right? So for example, if you're iterating through a container and you use any type, it may work because you only have integers but in your container, but as soon as someone adds a string, you'll get a runtime error and a customer code. Right? But if you wrote the clean code, then the contents of that iteration would be a different method where you define the any type, and then it would work. Which brings us to exactly the opposite of any type, which is extended data types. Basically, the idea is, and I hate this in C# really, instead of using string for everything that's a string, then let's be more precise about what that string contains. It could be a file name, it could be an account number, it could be whatever you like. Right? So when I in C# see a method that takes string, 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 perhaps I gave the parameters some good names to explain what it is. But why not use a hierarchy of types? And that's where extended data type comes in. So here we also have hierarchies like you know for classes. It's a hierarchy, so you can have, say, an account number, which is a string. Then we have something called a customer account number, which is an account number for customers. We have a vendor account number, which is also an account number, but for vendors. So we want to be as explicit in the types as possible. So just like you wouldn't use any type, I would argue you wouldn't use strings, int, any of these others either, because there's something better. We can see what the intent is. And we got a brand new feature in X++ a half year ago that can enable compiler checks. So if you call this method with a file name, it will tell you that you have a problem. That is actually pretty awesome. Right? The way you enable this is per type. So on an extended data type, when you define it, you can say enforce hierarchy, default is false or whatever, and then you can flip it to yes. So when you define new extended data type, set this one to yes, then you know that it will always be used correctly. But that's actually pretty nice. So we want to be as explicit as customers can understand. That's the whole idea here. Then we have something called macros. And that's another one of these that we would like not to have. But this language was invented back in the days where you had like a pre-compiler parser, which would then, whenever it sees a macro, it will basically just take that text literal and paste in when it's referenced. So you define a macro with hashtag define dot, the name of the macro, and then in parentheses, whatever you want. So this here is seconds per day, 24 hours times 60 times 60, that's how many seconds we have per day. And then the compiler will actually not really see this. It's the parser that sees this. And then when the parser comes to this, it says days, this guy, and then says, oh, there's a hashtag here, then it will take this string and put in here. So not as an integer, nothing smart. It wouldn't do the multiplication. It will just take that string and give that to the compiler. So you might as well have defined this here. That's what's happening. So that's a macro. Later on, we got constant int. So I would prefer that you write like this instead. Then you have type check and all of that, right? But you will see macros in there. And macros can also be used in libraries. So we have a library called time constants. So this one will then go to the metadata and find a macro library called time constants, which contains Brazilian constants, paste that in, which will then make the compiler read all these definitions. And in there, it will find 1 for seconds per day, which will then take what I just placed before. Right? So the compiler is a little bit on overtime here. It can handle it, no problem. But that's how it works. So when you see some of these, you need to search backward in the hierarchy to see, okay, why is it defined, and go look it up. Eventually, you will find it, or you just search in the code base. And you can also have macros with parameters. So you define a macro here called add that takes 1 and 2 and adds them together. And then you can return and call it with A and B. So there are a few cases where that is useful, primarily when you have some very complicated SQL statements where you're joining tables, and we have some macros that are joining very complicated stuff. And then it's really nice. You don't have to repeat the same thing over and over and over again. Right? Then you can use this. Ideally, the SQL statements are not methods, right? So you cannot really define a nice way around it. It's that kind of thing you need to write. So it's basically nice that we can have the compiler generate some of that for us based on a template of sorts. You will also see a double colon. You probably saw it already. It's basically how we reference static methods or elements in an enum. This is how it is. Binary operators. Can any one of you tell me what B will be if I run this? I have no idea what it is. I didn't even want to run it, because if I see something like this in code, I'll say, can we please add some parentheses to be explicit? But some people prefer to not write as much code, so they remove and they know better. They know how this works, right? Which is fine, but in reality, X++ behaves differently than some other languages, and I'm not quite sure. But we have seen bugs in this, and it comes up when you debug, and hey, why is it doing that? X++ is broken. It's like, I discovered the bug of the year, and I just add the parentheses. Right? We cannot change it, and I'm not sure what's right or not. Right? In some languages, it can take precedence. In others, it just reading left to right at the parentheses, and then don't be surprised, because it is perhaps different from what you used to. Let's see that. Then there's objects. So the root of all classes is object, like we're used to. And in C#, probably in Java as well, there's only very few methods on object. There's toString, perhaps a few more, but that's basically it. And if you try to call something else, you'll get a compiler error, because they're not there. We don't know what they are. In X++, we don't validate anything on object. So if you want to call a method that may or may not be there, just leave it up to the runtime to determine if this will succeed. We have some objects like form run. A form is the UI pieces we're building, and they are not like classes with a hierarchy and stuff like that. So we have 10,000 forms. They have their own names, but they do not have a type in like you would normally expect. So they're like created at runtime, basically. And if you need to call a method from the outside of that form on the form, right? And sometimes we do that because we have some class that supports different forms. How do you call that method if you cannot? Because form run doesn't have the method, and if you want to call it, then you can go through some kind of reflection APIs, of course. But then they came up with this shorthand instead. So typically before this, you will see a method to like form has method, and you put in this to make sure you avoid it in case it doesn't. The proper way of doing this is to use an interface. Forms can implement an interface like, OO style, right? You define what method it has without providing the implementation, and you can cast to the interface and call it, and it will be strongly typed. But object has this odd behavior. There's no compile check on it. That's the whole purpose of this, to call a method that I know it's there because I created it, but the compiler cannot validate. It's one of those that come back and bite us, because then some customer changed it. And also there's no when you right-click a method, you can see who is using this. We call it find references. It will not pick this up because the compiler doesn't know. So we see errors like this. This method is not used. Let me just delete it. Namespaces. X++ do not support namespaces. So we define all our types, give them a name, and they are all compiled into Microsoft.Dynamics. Something. But that's hard-coded somewhere in the platform. So everything is in the same namespace, which makes it a little bit harder. So we have a way around it. We have naming conventions. So we use like everything starting with COST, cost belongs to the costing module, for example. That's how we do it. That said, if you want to reference something in the CLR, you can reference that using namespaces. You can write system.reflection.whatever, system.diagnostic.stopwatch, or whatever you want. So we support that when you define types, but you cannot, when you create an X++ class or extended data type, put it in a namespace. I mentioned earlier we had a 3-tier architecture, and that meant we had client-server keywords. And at some point, we wrote a tool after we converted to the cloud because we no longer have client-server to just remove those keywords. So this is some code I found last week. Okay, create server-bound instance of blah. Everything is server-bound, right? It has a method called expand node search on server. I'm sure there's another one called on client. Right? And I'm sure this one said server right there at some point. It doesn't anymore. Right? So you will come across code that says, hey, create something on the client, create something on everything runs on the server. That's the only place things can run. And it's kind of confusing that we have this logic, but don't be confused by it. It's someone said, I think it's a guy, Uncle Bob, the one from Clean Code, he said comments are lies. This is an example of that, right? Whatever you write in comments is not something that the compiler will check, so over time it becomes lies. So it's better to express your code using names and types and stuff like that. That's where Clean Code is coming from. But here even the method name is wrong, and we ran a tool to delete most of these. You may also come across semicolons like this one, a dangling semicolon. You can just delete them. They are not needed anymore. You can read more about what happened there. It all comes back to X++ being case insensitive. So earlier versions of the compiler, when it saw tree node here, it could not distinguish it from the tree node here, which is a type or the variable. So it would assume that if you start with something that could be a type, it was a type. And then that equal sign would give you a compile error. So the way to tell the compiler I didn't mean the type, I actually meant that the variable is you put a semicolon because you put that after all the variable declarations, which comes first, and then the compiler would know better. Doesn't matter anymore. The compiler is smart enough to say, oh, an equal sign is looking ahead. So, oh, there's an equal coming next, and I know what you mean. Right, so just like you would expect. But if you see it, just delete it, move on. It's fine. Often we apply what I call the Boy Scout rule when we write code, which means we're leaving the campground a little bit nicer than we found it. So when you come across something like this, just clean it up. Don't think about it, just clean it up. We had scanners deleting some of these, but you may come across it. If you see something, if you see a typo or something, fix it up. So if you want to learn about X++, there's the language reference, kind of tedious to read, but it basically contains it all. Then in this book, there's a chapter which has actually been updated in all the versions of the book, so it's pretty up to date as of 2015. Right. So what happens after I wrote for myself a blog post? So if I ever should come back and update the book, then this is everything, and basically contains some 19-page like things I should remember to add, so you can read about here. But it's stuff that you recognize from C#. We got read-only and const. We got those things. The internal keywords started working. Client-server keywords disappeared. Basically, stuff I've covered here. But if you really want to read all of it, that's where to start. But basically, I think X++ is a perfect name for the most extensible language on the planet, and I truly believe this. We came up with something called chain of command, which is a way of extending logic without changing it. And at some point when I'm looking back on my career, I think that's the part I will be most proud about. So it actually adds something new to object-oriented programming. I'll talk more about what it is in the future tomorrow. But just the fact that we had X++ made this possible. And when we moved to the cloud, we wanted to solve the problem that they're all editing our source code, meaning they couldn't upgrade, we couldn't debug it. By April 1st, 2019, you have to have all our customers on the same version. No more can they change our source code. You need to seal all of it. And so that gave us a year and a half to solve this problem, and our ecosystem depended on it. So how do you do this in other languages? How do you extend it? Well, you raise events before and after you call methods or when certain things happen. So we started out by adding events, all the different places it makes sense to have events. 55 million lines of code would then become 100 million lines of code. I mean, everything was just bloating and it became unmaintainable. We had to document all of this. It was like a big concern for us. We were basically ruining the product and we were getting nowhere. So we came up with something else we call chain of command, which is a kind of a way of extending, but without using deriving, which would allow you to actually wrap a method with your own logics to call stuff before and after, and gave a lot of cool features. But that is why X++ is the most extensible language. It's super cool. And if we didn't have X++ but used Java, C# or what have you, we would never have been able to do this. So we actually leveraged this power, and that came out of the X++ team.